This Dempster Shafer theory is being released because of the following reasons. In the Bayesian theory, we consider only the single evidences of the single probability, and the probability cannot be displayed for ignorance. We are considering only the acceptance probability, and the ignorance probability is not considered in the Bayesian probability theory. To overcome this drawback, we go for the next one, that is the Dempster Shafer theory. In this theory, we are considering both the ignorance as well as this belief. For example, consider a room where 4 persons are presented, that is A, B, C, and D. After sometimes the power went off, and then finally one person was murdered. Our aim is to find who is the murderer. That is our objective or the goal. How can you find that one? Because A, B, C, D, one of the person is killed and other 3 possibilities are there. Can be done by A and C, or can be done by A and B, or C and D. So many possibilities are there. It's a combination. Or A can alone do this one, or C can alone this one here. B is no more. So A, C, and D are there. What are the probabilities? Sometimes automatically he may die. That is null set. No one can kill. That is one probability. Another one is A may kill the person, C may kill the person, D may kill the person, or the combination of AC, CD, or AD. So totally 8 possibilities are there. How can you identify which is having the higher probability? In this kind of uncertainty, we will go for what are the possibilities, identify the possibilities, and whichever having the higher mass percentage, that will be considered for the final answer. For this kind of uncertainties, you are not knowing the fact about this one. We are considering some hypothesis and we will try to prove that one. This is the evidence-based theory. It contains all possible outcomes. I told all possible outcomes of the problem. Hence, it is used to solve problems where there may be a chance that the different evidences will lead to some different solutions. We are considering all the possibilities. This is designed to deal with distinction between uncertainty as well as the ignorance. The ignorance samples can also be considered for identifying the problem statement. Rather than calculating the probability of proportional, it computes probability that the evidence supports proportions. It take the supports proportions also. Where we have if the insufficient information about this belief is there, we'll go for this one. That is what all are the combinations. Suppose a person is affected with this flu, means what are the possibilities? He may contain cough, or he may sometimes contain sneezing. What are the possibilities? Sneezing can also be there. Which one is having the higher priority? That you will identify using this Dempster Shafer theory. So belief will lead to get, we'll consider 2 terms. First one is the belief and next one is the plausibility. Believe in some possibility. Believe means belief, that is there, always there. We are believing that that's always sun rises in the east. That is, we are believing that. That is what called as the belief. Plausibility means make evidences compatibility with possible outcomes. Sometimes there may be a possibility of this one also. Always Ram will get good marks. That is the belief of the teacher. Sometimes Raju can also get good marks. That is the plausibility. All the possibilities are considered, means that's what called as the plausibility. Belief means definitely. Plausibility means more considerably. Here the ignorance is reduced. We can consider all the people. Combination rule is used to avoid this ignorance. Consider, these are the key factors considered in the Dempster Shafer theory. First one is the all the discernments and power set. Mass function assigns some value for each and every subsets, and belief, total belief exactly supporting a proposition, and plausibility is the total belief possibly supporting a proposition. These concepts are considering when you are going to prove certain problems by using this Dempster Shafer theory. This is the formula to calculate the plausibility. Plausibility is equal to 1 minus belief. Example, consider there exists one situation. cause flu, cold, and pneumonia. The possibility of this one is the combination of this one, certainly believing that if flu is there, then there is a possibility of pneumonia and cold is also there. That is 0.6. Not possible is 0.4. That is the plausibility that it is not possible. M2 is another belief observing that running nose is also there. Then there is also a possibility of cold. The belief for that one is, we know that running nose is mostly it will be a symptom of cold. So the belief for that one is 0.8 and uncertainty is 0.2. From that one, from this one, we can, this is what called as the mass function. Mass function for the combined flu, cold, and pneumonia is 0.6 and all flu, cold is 0.8. From that one, we can create another subset such that it will also support our solution space. Consider uncertainty is flu, measles, cold, and cough. These are the uncertainties. From this one, we are going to calculate which combination is having the higher priority. Where M is called as the belief function and mass of all the functions equal to 1. If you have all the functions includes 1. Let's solve a small problem. Example 1, where this uncertainty is flu, measles, cold, and cough, and M tends to belief function. Belief function of all possibilities 1. We require evidences that for this problem it's given that first combination M1 is flu and measles is 0.8 and then uncertainty is 0.2. This is the belief and M1 of U equal to 0.2. Same manner it's given that flu and cold M value equal to 0.6 and the uncertainty for this one is 0.4. These values are given. When you add this M1 and M of U, you'll get 1. If you add these two functions, the probability, the uncertainty function equal to 1. So here two things are given. From this one, by using this DST theory, we are going to conclude the proof. We are going to generate another one hypothesis such that this is the formula used to find this one. Intersection B equal to M1 of A into M2 of A divided by 1 minus summation of M1 of A into M2 of A. We are going to calculate the possibility of M3 of C. For combining this M1 and M2, we are going to form this confidence table. This table is called as the confidence table. One side you take one possibility, that is M1. Another one side you take M2. Row is M1 means column will represent M2. Now, here you see 0.8, 0.2. I have written that one. Flu and measles is 0.8 and uncertainty for this one is not happening to this one is 0.2. This is given here. Similarly, M2 is flu and cold is 0.6 and the opposite is 0.4. If you add these two, you'll get 1 and similarly, if you add these two, you'll get 1. Here we are combining, multiplying these things to form the table. So multiply this 0.8 and 0.6, 0.8 and 0.6 is 0.48. Similarly, find the intersection between these two things. To find the intersection between these two things, what will get? Find the intersection. This is flu and measles. This is flu and cold. When you take the intersection of these two, you get flu. Flu is common here as well as here. So what is the intersection? M3. The new fact is M3 of flu equal to 0.48. Same manner, find the intersection between these two. Here, this is flu and measles. This is equal to all. That means 1. You are going to multiply this with 1. That's the meaning of this one. If you multiply this with 1, you will get M3 of same thing. Flu into measles equal to 0.3. You know that if anything multiplied by 1 is equal to same thing. So that is equal to 0.3 to 0.8 into 0.4, 0.32. Same manner, multiply this 0.2 into 0.6. So this is anything. This is like 1. So 1 into flu and cold. M3 of flu and cold equal to 0.12 and M1 of everything and this is M1 of everything. So yeah, this is all 1 into 1. 1 into 1 is always 1. If you multiply this one, 0.2 into 0.4, 0.08. So the mass function for all the intersection, this is the theorem. According to the theorem, if you find the intersection, multiply these two weights. So this is what the actual production. So from here you can write another, we are going to take another evidences also. Now we know what is M3? M3 of flu and cold is 0.12, M3 of flu alone is 0.48, M3 of flu and measles is 0.32, and M3 of all is 0.08. Now another one's uncertainty is also added. When you see over here, nothing is 5. Out here all the values are there. If all the values are there, we cannot say there is that will not come. There is a possibility of all these combinations. So I am going to add one more component, one more mass function over here. That is, I'm considering sneezing. And M for cold cough with sneezing is 0.7, and everything is 1 minus 0.7 equal to 0.3. Now I am going to combine M3 and M4. Combine M3 and M4. What are the possibilities for M3? There are 4 possibilities. M3 of flu, M3 of flu and cold, M3 of flu and measles, M3 of all. You should write that thing here. All these things are written here. And next I'm going to add this M4. M4 of cold and cough is 0.7. M4 of all is 0.3 and certain. So this is 0.7 and 0.3. Now I can add these two things. According to the Dempster Shafer theory, I'll find the intersection and multiply the values. Here it is flu and here it is cold and cough. This is flu, cold and cough. Then what is the intersection? Nothing is a common one. Then that is 5. Nothing is there. 5. Intersection. M new factor I have added. New mass. M5 of 5 equal to multiply 0.7 and 0.48. You will get 0.336. Same manner. This is all. All means 1. So M3 of flu will get the new thing also. M derived M5 of flu equal to multiply these two things. You'll get 0.114. Same manner. M3 of flu cold. Previously, we have drawn this one. From that one, take the intersection of these two. If you take the intersection of these two, cold is there. So M5 of cold equal to 0.12 equal to 0.7, 0.084. Similarly, M5 of all means M5 of flu and cold equal to 0.036, 0.3 into 0.12. Similarly, flu, measles and cold cough. Here, if you take the intersection, nothing is there. So M5 of nothing equal to 0.224. And then if you find this intersection of 1 with this one, we'll get flu and measles equal to 0.096. Okay, just we are multiplying these two elements. Then this is all right. 1 into this means M5 of cold and cough is 0.056, and M5 of this is 1 and 1. This M5 of u equal to 0.024. So after adding the new parameter sneezing, what will be the probability or what will be the possibility of this assumption? For that one, first consider the summation of belief of null set. Here previously there was no null set, so we didn't take anything. We cannot conclude anything. But here there is a possibility of null set. Null set means not at all possible. Take the belief of the null set, add this value here. This is the null set. This is also the null set. Take two null sets, 0.336 plus 0.224. So belief of null set is equal to 0.56. We get this value equal to 0.56. By using this formula, we can calculate this. This one, when you see here, this is the formula for calculating this. You see here, this is the formula for belief and plausibility. We have calculated the belief. Belief is here, the belief is 0.56. Belief of the null set, and by formula, the belief is 1 minus 0.5 is equal to plausibility is equal to 0.44. So this is the normalized values. Normalize these values. Normalize now, divide all the values by this 0.44. Okay, here you are. Divide all the values by 0.44. You will get, take M5 because that is our final mass calculation. M5 of 5 equal to M5 of flu. You need to take the null set. Already you have taken the null set, and from that only you have derived its normalization factor. So now calculate M5 of flu. M5 of flu is 0.114 by 0.44. Normalize. Because there is two null sets, normalize the values with the null set, will get 0.327. M5 of cold equal to 0.084 divided by 0.44, that is equal to 0.191. Flu cold equal to 0.036 divided by 0.44 equal to 0.082. Same manner, calculate it for the flu and measles, that is this one, equal to 0.218. So after normalizing all these values, we got 0.327, 0.191 and 0.0082, 0.281. From that, what we can conclude from this one, we'll conclude that here the value is high for flu. This value is high for flu. So flu is the belief one. For this data set, flu will be there. But we are introducing the new factor, the sneezing. Whether the sneezing will affect the flu. In the flu case where there is a sneezing. Here the value is 0.56. 0.56 means that is above 50%. If it is above 50%, the belief is above 50%, then we can take that new factor. That is, new factor we are considering is the sneezing. By adding sneezing, this can, that is cold, cough and flu. The combination of this is also possible. That's the conclusion of this one. Suppose this value is 0.2 or 0.3 or 0.4 means less than 50%. So we will not take this confidence level and we can conclude that our hypothesis is wrong. What is our hypothesis means? By adding the sneezing to the flu, by adding sneezing, cold and cough, there is a possibility of flu also. We conclude that there is a possibility of flu with cold, cough and sneezing. So this is used to identify the possibility or the chances of this uncertainties with the help of adding one or more factors. That's all about this Dempster chapter algorithm. I have shared on YouTube link also. You go through the link for simple problem. This is also possible. In the next class, that is tomorrow's class, we'll solve another examples for this one. You'll get a good knowledge.